today we'll be doing class 7 magnetism, and we'll further continue magnetism today. And today we'll be discussing about the topic in magnetism which is called electromagnetism, okay, or an electromagnet. Now, what is an electromagnet? So, electromagnet is a type of device. Okay, it's a magnet in which a magnetic field is produced because of the current which flows through the wire. Okay, say you connect a wire, the battery, and you connect the wire to the battery, to two ends of the battery, and when you connect it, what happens? Current flows to the wire. Now, when the current flows to the wire, when current is flowing to the wire, you bring a metal. Okay, you bring any metal or an iron closer to it. What will you find? You see that there will be a little bit of attraction. Okay, what does it mean? It means that when the current was flowing through that wire, when current is flowing in and around, a magnetic field has been created. Okay, a magnetic field has been created in the path in which the current is flowing, and that is your electron. We call it to be an electromagnet. Now, see here. What is an electromagnet? It is a type of magnet in which the magnetic field is produced by an electric current. So when the current flows through a wire, a magnetic field is produced. Okay, it can be a strong magnetic field, it can be a weak magnetic field, but a magnetic field is always produced. The magnetic field disappears when the current is turned off. So as I told you, when the current is flowing, if you bring, say, this is a wire and the current is flowing to this wire, okay, you've connected it to the two ends of the battery, and say this is the wire and the current is flowing to the wire. Now I bring a magnetic substance closer to it. When I bring it closer to it, what will happen? I'll see there is an attraction. Okay, so what does it mean? A magnetic field has been created. Okay, so not only current is flowing to it, but there's a magnetic property also exists. Not only the electric current, but also a magnetic property exists. So when you bring it closer, you see that there will be a little bit of attraction. Now, depending upon the strength of the current, depending upon the strength of the magnetic field, we can say how strong or how weak the attraction can be. So this is your electromagnet. And as soon as you turn it off, which means when you just disconnect the wire with the battery, the one which is attracted to it automatically will be down. Okay. So what does it mean? It means when the current stops flowing, when the current does not flow, when the current stops flowing, the object or the magnetic field will be weak. That means it will lose its magnetism, and thus the attracted magnetic substance will fall off. And what does it mean when the substance falls off? It means there is no magnetic strength acting on the magnetic substance. Okay. So electromagnets usually consist of a large number of closely spaced turns of wire or coil that creates the magnetic field. Now you can see here, we take an iron core or iron bar or anything which is made up of iron or steel, and you can see, here an iron core is used, and then the line that you see over here is the wire which has been wound around which has been turned around the bar. Okay, say this is your bar, and there will be wire which will be turned around it. That means you coil the wire around the bar. Okay, so the line that you see over here is your copper wire. Now this copper wire is connected to the two ends of the battery, the plus and the minus side. This is a symbol of battery. The smaller one, the longer line. Okay, symbol of battery. And the one that you see is the key. Key means, like the switch which you turn it on and turn it off. Okay. So when you connect the switch, when you connect the key, what will happen? Current will start flowing. Okay, as the current starts flowing, you bring an iron nail closer to this. When you bring an iron nail closer to this iron core, what will happen? It will get attracted to this. Okay, it will be attracted to it. So what does it mean? It means when the current is flowing through this iron core, okay, or an iron bar, it also acts as a magnet. Okay, it acts as a temporary magnet. So that's why it attracts the iron nail. Okay, so when you turn this off, when you disconnect this, when you disconnect, there will be no flow of current. The current will stop flowing. As soon as the current stops flowing, the iron nail which you have placed here, which has been attracted here, will fall off. Which means this will no longer be acting as magnet. Okay, that means there has been no magnetic field in and around. So this is your electromagnet. This is your electromagnet. This is how an electromagnet is made. You take an iron core or an iron bar, and then you wind the coils around it, copper coils around it, okay? And then you connect the coils to the battery. And when you connect it to the battery, current will start flowing. And when the current starts flowing, this bar of iron, this will act as a magnet. Okay, temporarily this will act as a magnet. So if you bring any magnetic substance closer to this, it will get attracted to the bar. And when you disconnect this, when you disconnect the flow of current, that means when you take off the wire or disconnect it from the battery, no current will be flowing to the wire. If no current flows to the wire, the iron nail which has been attracted to this iron bar will fall off. And what does it mean? It means that this iron bar is no longer acting as magnet. Okay. So electromagnet is a solenoid with a soft iron core. When using the iron, the magnet is temporary. When using steel, the magnet is permanent. So if you use this core or a bar, if you use this core or a bar, it's made up of steel. So instead of iron, if you use this core made up of steel, it will be a permanent magnet. And if you use this as iron, it will be a temporary magnet. Okay. Now you can see it, most of you have done it yourself only in the school itself, isn't it? You take an iron nail which is acting as an iron bar. You can see the brown one here. The brown one represents the copper wire. And then you connect it to the two ends of the battery. The wire is connected to the two ends of the battery. Now you bring any magnetic substance closer to it. And you can see a nail here. So any magnetic substance closer to it, it will be attracted. As soon as you take this off or disconnect it from the battery, it will not be acting as magnet. So this is your electromagnet. Okay. Now how to make an electromagnet? There are three ways to make electromagnets and stronger. That means we can see the strength of the electromagnet depends upon these factors. Okay. The first one, more turns on the coil. So if you turn more number of coils, we don't have anything over here. So if you turn the number of coils around it, okay, if you turn the coils around it, the more number of coils you wind around it, more stronger will be the magnet. It will be a strong magnet. Okay, if you wind more number of coils around it, that means if you just completely fill this bar with copper wire. Okay, if you just wrap it around just with small amount of wire, that means it will be a weak magnet. So more the number of turns of the coil, more stronger will be the magnet. Second one, depending upon the strength of the battery. Okay, if you take a higher volt, if you take a strong battery, if you take a higher volt, what will happen? More current will flow through it. So more current flows, more stronger will be the magnet. If weaker amount of current is flowing to the coil, bar will be acting as a weak magnet. Another one is using an iron core. So if you use an iron core, it will be a temporary magnet and a better magnet. Okay. So what happens if you turn the battery around in an electromagnet? That means you flip the battery. The poles of the coil are reversed. That means north becomes south and south becomes north. So say you've been using a battery and you just change the position of the battery. If you have been connected to the negative side with the coil, you change it and you connect it to the positive side. The end of the coil which has been connected to the positive, take it to the negative. So when you change the position of the coil, what will happen? Even the north pole and the south pole will be changed for the magnet. So say if you change say this is north pole and this is south pole. If you change the position of the battery, okay, the connection to the battery, what will happen? This north pole will become south and south will become north. So when you change the position of the battery, the poles also get changed. Okay. So this is what means the pole on the coil reverse, north becomes south and south becomes north. Now uses of electromagnets. It's used in our day-to-day life. You've seen it in television, motors, isn't it? Every day even those cranes, big cranes, they use electromagnets. So we have it every now and then. Electromagnets, magnets powered by electricity. Electromagnets can be turned on or off when electricity is flowing to the magnets. Okay, not this one. See here we have. It's used in devices such as motors, generators, relays, loudspeakers, hard disks, MRI machines, scientific instruments, and magnetic separation equipment, and many more with the televisions. Now this is your electric bell, and this is how an electric bell works. Okay, this is how an electric bell. You've seen an electric bell at home, isn't it? When you switch it on, a ring bells. You can hear the sound, isn't it? And when you disconnect it, when you just take your hands off the switch, no longer will the bell ring. So this is how the internal structure of the bell, electric bell would be like. Okay, so this is your iron and the wires are wound around it. So these are acting like magnets. Okay, these are electromagnets, or these are like electromagnets. It's connected, the wires are connected to the battery. The switch, this is your switch, and there is a gong over here and a hammer. There is a hammer-like structure here. Okay, now this is a gong, the big round gong, and this is your hammer. Now when you switch it on, when you switch this on, what will happen? Current will start flowing through the wire, and once the current starts flowing through the wire, okay, when the current flows through the wire, this bar will act as a magnet, okay, which will act as an electromagnet. So they will act as a magnet, they will attract this iron strip, okay, they will attract this iron strip closer to it. When the attraction happens, this will move closer to this. Now when it moves closer, this hammer will hit the gong. When the hammer hits the gong, that means when it comes closer, the bell will ring. Okay, when you take your hands off the switch, what will happen? No current will flow through this wire. And when there is no current, this will be detached from the gong. That means no sound will be heard. Okay, there will be no ring. Okay, you will not be able to hear the bell ring further. That's why when there is no current, no electricity, you cannot press, even if you press the key or the switch, nothing will happen. You don't hear the bell ring, isn't it? It is because it works on electricity. Now you know it, this is your structure of a electric bell. You have the battery, you have two iron bars which are wound by the copper wire, okay, which is connected to the battery, and the battery is connected to the switch. And there is an iron bar strip over here, okay, and this is a hammer and there is a gong. Now the gong and the hammer, they are used for ringing the bell, and the entire concept is of the electromagnet. When current flows through the wire, the bars which are here, these bars, they act as electromagnet. That means they act as magnet. When they act as magnet, the iron strip bar which is closer to it will be attracted towards them. So when they lean towards them, this hammer will hit the gong. When the hammer hits the gong, the bell will ring. So now see here, process of the working of an electric bell. The switch is pressed and the current flows through the circuit. The electromagnet is powered and generates a magnetic field that attracts the iron strip towards it. When the striking arm strikes the gong, the contact is broken and the current stops flowing through the circuit. Okay, so this is how an electric bell works. And this is the last part which is not there in your book, just for your knowledge. These are the different types of magnets that we see in and around. And most commonly we use this bar magnet, cylindrical magnet, horseshoe magnet. These are the same horseshoe magnets. We don't use circular magnets and ring magnets. So these are the different types of magnets that you see in and around. And these are the temporary magnets. Okay. You know the permanent magnet, the example of permanent magnet is the lodestone that we get. And the concept of electromagnet was discovered by the Danish scientist Hans Christian Ørsted. Okay, when he was doing some experiment where the current was flowing, he could see there was an iron nail closer to it, and he could see the deflection, the attraction. So with that he got into the concept of electromagnetism. So I hope you understood till here, and with this we complete the chapter. If there's any doubt regarding magnetism, please do ask. Thank you and have a good day.